Hey guys, I'm Ivy. I work on the Innovation Lab here at Finastra, and today I'm going to do a deep dive into cryptocurrency wallets. We're going to talk a little bit about what they are, how to use them, the technology behind them, and then I'm also going to show you how to set up a new one and how to use this with other decentralized applications, which are also called dApps, by the way. This is actually my second hackathon learning session. The first one that I did was focused more on understanding the technology behind the blockchain. We also talked about the different factors that influence the valuation of each cryptocurrency. So if you have a second, definitely check that one out too, and we'll link it along with this one so you guys have access to it. Okay, so here are some of the topics that I'm going to cover today. First, I'm going to take you through a comparison between a physical transaction and a crypto transaction, and I'm going to draw some similarities and also highlight some key differences so that you guys can kind of understand how crypto transactions kind of translate from physical transactions and how they can be used to represent the same thing. Next, let's talk about the different types of crypto wallets. So each one has its own security benefits as well as some drawbacks and trade-offs. So I think those are important to consider when looking for a wallet. So we'll definitely talk about those. Next, I want to talk about your public and private keys. So public and private keys are extremely, extremely, extremely important in cryptocurrency. So I want to talk about what they mean, how to use them, and also how they work to secure your transactions. So for the last part of this presentation, I want to do a demo of how to create a MetaMask wallet. And MetaMask is one of the most popular Ethereum compatible wallets. So I'll show you how to make one and then how to connect it and use it with other dApps. So understanding transactions. Let's try to understand what transactions actually mean and what they represent. So I think all of us are pretty familiar with physical transactions just because of how often we come across them in everyday life. So let's say that we're doing a physical transaction, and let's say that Alice is selling a camera to Bob. Now, in order for this transaction to work, Alice has to have the ownership rights to the camera in order for the item to be exchanged, and then simultaneously, there has to be some sort of like monetary transfer from Bob to Alice. So what's really happening here is that there's a change in ownership. So the camera goes from Alice to Bob. And then when Bob physically hands Alice the cash, there is a change in ownership of the money. So if we take a step back and maybe forget about the items, so regardless of the items that are being exchanged, we can see that whatever is transacted kind of switches ownership. Now, with physical transactions, there has to be some level of trust. So both Alice and Bob need to trust that they are both going to show up at their agreed time and place. Alice has to trust Bob that he's going to show up with the exact amount of money that she wants for her camera. Bob has to trust Alice that she is selling a camera that functions the way it's supposed to and that she's selling it with the correct ownership rights. If it wasn't actually her camera, and maybe if it was like a stolen camera, then that could potentially create problems for Bob's ownership later. So we do see that there has to be some sort of trust between them. Now let's take a look at the cryptocurrency transaction. So let's say that instead of selling a camera and instead of meeting up in person, Alice is now selling a Bored Ape Yacht Club digital asset NFT to Bob. So the key difference is that with crypto, the funds are intangible, meaning, we can't really touch it and the money isn't physically there. So instead of Bob handing Alice some cash, he's really just transferring ownership of the cryptocurrency that once belonged to him. So with our physical transaction, the cash that Bob handed Alice changed ownership because the cash physically exchanged hands. But the basis of cryptocurrency and intangible money means that the monetary exchange can actually happen without the money physically changing hands. So pretty much crypto transactions that are recorded in the blockchain are essentially just like tracking where the money moves and when the assets go through changes in ownership. So if we go back to our example, the ledger transaction of Alice's NFT sale would show that the NFT that was like previously owned by Alice but then passed to Bob, and then at the same time the crypto that Bob paid for the NFT would now be Alice's. Now, the way this works is that just say like a bank account, you have an account number and you have a password, right? In cryptocurrency, this is very similar to your public and private keys. Because it's secured by cryptography, your account number and your password are like algorithmically generated. So you don't really get to choose your username and password. Another key difference is that in the physical transaction, we saw that both parties had to trust each other. But the blockchain is trustless, meaning that two individuals transacting on the blockchain don't need any trust. So Bob doesn't need to trust that Alice is selling him a real Bored Ape Yacht Club NFT because he can transact through the network that secures this and verifies this for him. And then at the same time, Alice doesn't need to trust that Bob has fake money or that he won't pay what she asked for because, again, the blockchain will automatically and securely do the asset transfer. So blockchains secure this trust with cryptography and consensus mechanisms, which pretty much validate and ensure your transactions. So this means that the blockchain is going to trust any transaction that is signed by your private key. And this is something that we'll actually discuss in more detail in a second. So now let's look at the different types of wallets. Before I get into this, I do want to say that it's a really common misconception that wallets hold your money. Your cryptocurrency wallets actually don't hold or store any of your funds. What they really do is they manage your private keys, and your private keys are used to digitally sign your cryptocurrency transactions. So the wallet is a software that interacts with the blockchain, and it's kind of like a keychain or like a storage vault for your keys. So here I've underlined the more secure option between each type, but now let's go through the details. So when we're looking at hardware versus software wallets, hardware wallets are physical devices that already have the wallet software on them. And some examples are Trezor, Ledger, these are the most popular. While software wallets are downloadable applications on your choice of a compatible device. So some examples are like MetaMask and the Coinbase wallet. And by the way, the Coinbase wallet is actually a different app from buying and holding your coins on the Coinbase Exchange app. So the trade-off here is that with a hardware wallet, you don't have complete accessibility of your funds because you can only access them on that hardware specific device. And it usually comes in the form of like a USB drive or a flash drive. So with software wallets, there is more flexibility because you can access your wallet through your private keys by downloading the application on any new device. So if you have like MetaMask on your phone and you lose your phone, it's okay because as long as you have the private key saved, you can still download the software on another device like your computer, your iPad, or even another friend's phone, and then import your wallet with your private keys. So hardware is definitely more secure because you have to have the device for every transaction. Now, with hot wallets and cold wallets, the difference is that hot wallets are accessible via the internet, so they are easier to use. Cold storage wallets are downloaded and they reside offline, so usually on like a piece of hardware like a USB drive or a smartphone, and most hardware wallets are cold. But some hardware wallets can connect to the internet and they do things like handling transactions and signing transactions and then sending those to the blockchain network. So cold wallets are definitely more secure because they're not connected to the internet. So with a custodial wallet, another party will control your private keys and you have to trust them to secure your funds. There's less personal and less individual responsibility, but if the exchange is hacked or something happens, then your funds could be at risk. With the non-custodial wallet, you do have sole control of your private keys and you don't need to trust a third party, but you have the responsibility of managing your keys. And we have this saying in crypto called not your keys, not your coins, which means that if you don't actually own the private keys to your coins, then you don't actually own your coins. I do also want to mention that most crypto attacks happen when a hacker gains access to a hot wallet on an exchange and then is able to transfer the funds. So again, hot wallets are less secure than cold wallets. And if you're holding your assets on an exchange, it means that you are trusting a third party to control your private keys. So with crypto wallets, you do have the ability to self-manage your money and you also have verifiable ownership of your coins. But at the same time, if you haven't backed up your information or stored a hard copy of your private keys somewhere, then you will lose your access completely. There's 100% user responsibility and losing your keys is irrecoverable, so you definitely have to manage your keys responsibly. I will say that there is a big learning curve with using this because some people can find addresses and keys really confusing, or wallet technology is not always the most user-friendly, and in order to, use crypto wallets and transact, you do have to know a little bit of background behind cryptocurrency and how to use the blockchain. So there's definitely a learning curve with using this technology. Okay, so now let's talk about the significance and the functionality of your public and private keys. So this is what we call public key cryptography. And without public key cryptography, crypto would not be possible. So with your public key, you can freely share this. This is the address that you give out when you're receiving funds. When you are the owner of a crypto asset, basically the ledger is going to show exactly which assets are held under your public address. And I will actually show you guys this in our demo later. Your public key is pretty much like a cryptographic code that's paired to your private key. So your public key and your private key are a pair. If you forget your public key, it's okay because your public key can be derived from your private key, but nobody can reverse engineer your private key from your address. Now, your private key, like the name suggests, should never, ever, ever, ever be shared with anyone. Actually, let's briefly discuss what's happening in the background mathematically. So your public key is like a product of two really, really, really large prime numbers. These numbers are so big, specifically they're 2048-bit numbers. So they're really, really big numbers. And to represent them with a little more human readability, we usually use hexadecimal notation. And in hexadecimal format, your public and private keys are made up of numbers 0 through 9 and then the letters A through F. So basically the reason we use prime numbers is because when you multiply them together, it's pretty much impossible. It's actually computationally infeasible to factor them down. So, if I said, what are the factors of 12? We could say, 1 and 12, 2 and 6, 3 and 4. But with really, really large prime numbers, we cannot factor them. And this is why we call them one-way functions, because we can go forward, but we can't go back. So this means that no one will ever be able to find out your private key from your public address. Now, your private keys completely control access of your funds by being the unique piece of information that is needed to create digital signatures. And digital signatures are required to sign transactions. So digital signatures are generated by using your public address in combination with your private key. So what's really happening is that the private key is used to sign the documents, and then the resulting digital signature is cryptographic proof. And this proof has 3 guarantees. And number 1 is authentication. So that means that this transaction must have been created by the authorized user. 2 is non-repudiation, which means that this user cannot ever deny having signed the transaction. And then 3 is integrity, which means that this transaction and its contents were not altered in transit. If there is no valid digital signature, then the blockchain will not honor the transaction. So remember back in our cryptographic transaction example, we talked about a change in ownership of the tokens. So in order to move the token, so if you're an owner of a token and you are trying to pay someone else, in order to move the token and reassign ownership requires the private key and the digital signature. So this ensures that, the sender is the rightful owner of the asset, and then the transactions are verified by other nodes on the network to ensure that the funds are handled and transferred properly. Okay, so that's all I have for the presentation, but now let's jump right into how to set up a MetaMask. So you're gonna go download the MetaMask extension from the Chrome Web Store and make sure that you are downloading the official MetaMask app. So we'll click Add to Chrome, we'll add the extension. So it says MetaMask has been added to Chrome. So you're gonna open MetaMask, hit Get Started. Here we're going to create a new wallet, but let's say that we create a new wallet and then you want to access this wallet on another device. When you create a wallet, you're going to get a private key, and all you have to do is once you download the MetaMask on your other device, you import your private key. So let's go ahead and create a wallet, and then you have to agree to their policies. Then you have to create a password. But I do want to emphasize that if you forget this password, it's okay, because all you would have to do, as long as you have your private key saved, is just import your private key. Okay, so let's create. Here's a video on MetaMask that I really encourage you guys to watch, but I will skip it for now. Now, MetaMask is a non-custodial and it's a hot software wallet. So again, this means that you have sole control of your private keys and responsibility. It's hot, meaning it's also connected to the internet, and then software wallet, meaning it's a downloadable application. This wallet is only Ethereum compatible, so don't send your Bitcoins or don't send any other cryptocurrency to this wallet without first verifying that your asset can transact through the Ethereum network. For example, Matic, the token of the Polygon network, is compatible with Ethereum. I'm going to reveal this private key so I can show you what it looks like. So here's our private key. The private key can come in different forms. It could be a mnemonic phrase, it could be a binary code, hexadecimal code, it could be a scannable QR code. It doesn't matter what form it's in, pretty much translates this astronomically large number. So nobody should be using this wallet address or send real funds to this wallet address because I have shown everyone this wallet's private key. So, and again, the private key controls access to all the funds. So nobody should be using this wallet. You can open as many wallets as you want. So I'm just going to open this wallet and probably never touch it again. So you hit next and it's going to ask you to confirm your private keys so that you do have them written down somewhere. So I will do this. And then we're going to hit confirm. And then it says, congratulations, you have to manage your private keys. So now that we have a new wallet set up, let's go through some of the information on here. So you can see that this is your account one. If you click it and you copy it to your clipboard, it will show your public address. So this is your public address. It is shown right here. You will see the ETH balance. You can also see transactions, but right now we don't have any. Okay, so now that you have a wallet opened, we need to fund this wallet. So just for the purposes of this demo, because I'm using a wallet in which, everyone watching this has seen the private keys, I'm going to use a test network because I don't want to deposit real ETH and I don't want to pay real gas fees. So let's use the Kovan test network. Now we need to fund the wallet. So I'm going to use what's called a faucet function, which means that this application is just going to deposit some test ether into the wallet. So pretty much in order to fund your wallet, the process is exactly the same. You just have to go to your exchange, buy some ETH, and then you'll have to click withdraw. And then when you withdraw it, you will withdraw it to your public address. So here I'm going to paste in the public address that we just made. Okay, so I just deposited some test ether into this wallet. And now you can see that there's a transaction under the activity and we can see that the account balance is updated. Now that we have the wallet funded, let's try to send a transaction. So we're going to hit send. And then we're going to paste in the address that you're sending it to. And let's say that we are going to send 0.0005 ETH. We're going to hit next. Now you can see that it's asking you to confirm the transaction. And remember when we talked about using your private key to sign and digitally signing your transactions, this is exactly where it's happening. So when you are moving your asset to somebody else, you have to confirm it. And this is where the wallet will automatically generate a digital signature and sign your transaction for you. This gas fee that we see here is the fee that you have to pay to use Ethereum. So anytime you're transacting or doing anything on the Ethereum network, you have to pay a gas fee. And this gas fee is calculated by how much computational power and how much resources you're using. So that's where the gas fee comes from. So hit confirm, and then you will see that the transaction is pending. Now, if we click on this transaction and we click View on Block Explorer, this is where we'll be able to see all of the information pertaining to our transaction. So Etherscan is the block explorer for Ethereum transactions. And what a block explorer is it's pretty much just an app that makes it easier to view and display the contents of the blockchain. So you can see this is the hash ID of the transaction. It was successful. This is the block number that it was included in. You have the timestamp. All of this is information that is mined and then secured by the blockchain. So you can use Etherscan to search all kinds of different data on the blockchain, looking at gas activity, looking at the node activity, looking at the token supply, the market cap. And these are all actually concepts that we talked about in my other hackathon learning session. So definitely check it out. Now, remember I said that I was going to show you that when you own a crypto asset, it shows under your public address. So we're going to go back, copy our account number, and then instead we're going to paste it up here and search what kind of information we get when we type in our public address. So once we look up the address on Etherscan, you can see all sorts of different information relating to this account. You can see the account balance. If you owned any NFTs or if you owned any other sort of tokens, all of those would show under here. It would show all of your transaction activity, all of your activity on dApps. And yeah, so this is all the information that you'll be able to see once you look up a public address. And again, let me mention that we're using the Kovan test network Etherscan. If you're transacting on the actual Ethereum blockchain and not a test network, you would just be using etherscan.io. So if I query this, there's going to be no activity because we haven't used our MetaMask address to actually transact on the Ethereum blockchain. So now I'm going to show you how to connect your wallet and use it on a decentralized application. So OpenSea is actually the biggest NFT marketplace, and I'm going to show you how to create an account. So you're just going to hit this button here, go to your profile. And if you haven't already connected your wallet, it's going to prompt you to connect a wallet. So you're going to connect your MetaMask. And this is how you connect your wallet and use it with other dApps. Now, I want to emphasize that you should only connect your wallet to trusted websites. Just be really, really careful about which websites that you connect and give permissions to, because once you give those permissions, those apps will be able to use your wallet. So we're going to hit next. And then you're going to connect it to this account. So you can see that once you connect it, OpenSea will be able to see address, account balance, activities, and suggest transactions. So you hit connect. And that's it. Now you have an OpenSea profile that is connected to your MetaMask address. Now let me show you how to buy an NFT. So we're going to go to the Bored Ape Yacht Club that Alice was selling. What you're going to do is, let's say that you wanted to buy this one, for example. You're just going to hit place bid and then go through the process of buying it. But that's pretty much how to connect your wallet to a decentralized application. So now I'm going to show you another example of connecting your MetaMask to a dApp, and this one is called Avi. So we're going to go to the Avi app and then hit next. It's going to ask for your wallet permissions again. And you have to connect. You do have to approve to connect your wallet with any dApp that you use. You first need to give the permissions. So Avi is a liquidity protocol. Pretty much they do the same thing a bank does, which is take in some money and then lend it out. But these rates are algorithmically adjusted based on things like the supply and the demand. So it is done in a fairer way than a bank. So let's say that you want to borrow or lend the stablecoin DAI. Now, because we already gave the dApp permissions to our wallet, it's now able to read our balance. So we don't have a DAI balance in here, but if we did, we would be able to deposit it into the protocol and then earn rewards or borrow the stablecoin and then pay interest and things like that. So yeah, that's another example of how to connect your MetaMask with the dApp. It's really simple. All you have to do is just give the right permissions. Again, I just want to emphasize that you should only connect your wallet to trusted websites. That's all I have for this demo. I hope you guys learned a lot about cryptocurrency wallets, how to track your transactions, things like public key cryptography. I know we don't have a Q&A session for this, but if you ever have questions, feel free to email me or reach out to me on Teams or whatever it is. I would be happy to answer. But thanks, guys. Thank you for listening in and joining the session. Bye.